welcome back to course Database Management System. So our today's topic of video is concurrent execution of a transaction and its problem. So in the previous video we have seen how to solve a numerical based on a conflict serializability. So we understand how conflict serializability problem can be solved. So today we are going to discuss about concurrent execution of transaction and due to which what are the problems that may occur. So that we are going to discuss in today's video. So what is transaction that we have already seen? In the layman way we can say that transaction is nothing but a set of one or more operation which is carried out one after another. So there are n number of definitions are there for transaction, or in short you can say that transaction is nothing but a change, okay, and that change should be consistent one. So if we consider a scenario in case of a banking or any other domain, that number of transactions takes place simultaneously, because we have seen the transaction can be executed in the two manner. One is a concurrent and second one is a serial. In case of serial, what we have seen that after completion of one transaction another transaction starts. So what is the problem in serial execution of a transaction? So in that case waiting time is more, because unless and until one transaction will not complete its execution, another transaction will not start its execution. So in that case what is the problem? That the waiting time for transaction is more. So in order to overcome this problem, we have the concept of concurrent execution of a transaction, where you have to run a multiple transaction at the same time and it perform various database updates simultaneously. Concurrent execution of transaction involves n number of transactions to be executed at the same time. And the concurrent execution of transaction concept is very much similar to the concept of multi-programming in operating system. In case of operating system, what we have seen, multiple programs are running at the same time. That means you are listening song, also you are doing programming, you are executing a program, and also you are listening a song. That means two tasks is being done at the same time. So this is what a multi-programming. In the same way, concurrent execution of transaction can also be done. So there are two reasons why we allow concurrent execution of transaction. Very first is improved throughput and resource utilization. So transaction may involve set of activities such as IO activity and CPU activity, and in case how it helps you to improve the throughput. So first of all, what do you mean by throughput? Throughput is nothing but a number of tasks executed per unit time. This is what a throughput. Suppose we are using a concept of concurrent execution, then the throughput can be improved, because in this case in case of concurrent execution more than one transaction can perform its task simultaneously. So n number of transactions can be executed at the same time. But in case of a serial execution of transaction, only one transaction will perform its execution at the same time. So concurrent execution of transaction helps to improve the throughput, as well as it also improve the utilization of a resource. This is the first reason that why we should go for concurrent execution of a transaction. Then the second reason is that reduce the waiting time. As I told you earlier, that concurrent execution of transaction we are going to reduce the waiting time, just like in a serial schedule. In case of a serial schedule, unless and until one transaction will not complete its execution, another transaction is not going to start its execution. So obviously in that case waiting time is more. For example, transaction T1 requires 1 hour to complete its execution, and transaction T2 required only 1 minute to complete its execution. So in that case transaction T1 has to run for 1 hour. So for 1 hour transaction T2 has to wait, but it requires only 1 minute of work. So in that case you face a lot of issues. So in that case I am telling you that we require a concurrent execution of a transaction. So concurrent execution of transaction help us to reduce the waiting time. So let's see the example. So this is a simple example where transaction T2 wants to deduct 50 rupees from A and transfer it to account B, whereas transaction T2 wants to transfer 10% of amount from account A to account B. So this is a concurrent execution of transaction. Why is it so? that transaction T1 is executed partially, then transaction T2 is executed partially, then again T1 perform partially. So that means here T1 completed its execution and also T2 has completed its execution. So in this case what we have seen that the waiting time for T2 get reduced. In the another way, what will happen that this instruction can be executed first by T1 and then T2 will start. But instead of this, what we have seen, transaction T1 executed partially, then T2 get a chance for its execution, again T1 and again T2. So in this way, concurrent execution of transaction helps to reduce the waiting time and increase the throughput as well as to increase the resource utilization. Okay, so this is what a concurrent execution of a transaction. But executing many transactions at the same time may involves lot of problem. So what are the three? There are three types of problem that may occur during concurrent execution of transaction. So these three problems are lost update problem, dirty read problem, and unrepeatable read problem. These are the three problems that may occur during concurrent execution of a transaction. So we will discuss all these three problems one by one along with the example. So we'll discuss these three problems. So very first problem that occurs due to concurrent execution of transaction is lost update problem. So what is a lost update problem? In a lost update problem, when two transactions access the same data base item, and in that case update made by one transaction is overwritten by another. So let's try to understand this problem with the help of example. So what is a lost update problem? Update made by one transaction is overwritten by another transaction, and due to which it causes inconsistency. So let's demonstrate this with the help of example. Now understand here there are two transactions are there, T1 and T2, and these are the timestamp. Timestamp represent that particular time that transaction perform its execution. So here we can say that at time T1, transaction T1 perform particular action. What action is there? It is going to read the value of E. So initial value is 50,000. Then at time T2, again transaction T2 reads the initial value of a loan, that is 50,000. Then at time T3, transaction T1 performs deposit operation where that 20,000 is being added to 50,000, and at time T4 T2 performs withdrawal operation over this e-loan account. Okay, so 30,000 is to be deducted from this 50,000. So in this case what will happen, transaction T1 will at time T5 transaction T1 will perform write operation. So in this case 50,000, that transaction T1 added 20,000, so its value is 70,000. But this is a final updated value which is to be read by T2, but this is not a case. T2 has read the initial value itself, only 50,000. That's why in this case in the final write operation made by T2 we see the 20,000, but actually here what we required 40,000. So this is what a lost update. So where lost update is being done, in this case updation made by T1 is overwritten by transaction T2. That's why finally we got this is a wrong value. Here we expect that T2 has to read the value 70,000, but T2 is reading the value 50,000 because whatever the changes made by transaction T1 is overwritten by T2. T2 is not going to read the value of T1. Whatever the changes made by T1 is not read by T2, but T2 is reading the stale value of that particular account. So in this case lost update problem will occur. So here we have mentioned that here lost update problem occurs, that is of 20,000. Actually here we need to have the value as a 40,000, but as T2 is not reading the updation made by T1, that's why here we see the value of 20,000. So this is what a lost update problem, where updation made by one transaction is overwritten by another transaction, and due to which it causes a inconsistency. So this is the first problem that is caused in concurrent execution of a transaction. Now we discuss about the second problem. What is the second problem? That is a dirty read problem. So what is a dirty read problem? So in that case, when one transaction update the database item and then transaction fails for some reason, but another transaction access the updated value before it change back to original one. So this is again simple dirty read problem. So we demonstrate this with the help of example. Again we consider this scenario where time is described with the help of t1 t2. Small t1 t2 represents the timestamp, whereas transaction here we need to perform two transactions. One is a t1 and second one is a t2, and here we have been given a set of actions. Okay, so at time t1, transaction t1 performs read operation on e-loan account where initial value is 50,000. Then t1 is going to add 20,000 to that account, and then t1 performs write operation. So one thing I want to clear to you is, though transaction perform write operation, but unless and until it will not going to perform commit operation, that changes will not save permanently in the database. So execution of a commit command is very important in case of a database. Suppose you are performing write operation, but after that you are now performing commit operation, then your changes will not get saved permanently in your database. So same thing is happening over here. Though t1 has read the initial value of e-loan, that is 50,000, then added 20,000 and then returned the value, but here transaction t1 is not committed. Okay, and at the same time transaction t2 comes and it is going to read the value of e-loan, that is 70,000, and then deducted 30,000 from it, and after that there is a rollback. Okay, see, there are three commands are there in TCL category. What is TCL category? Transaction command language. So in that case three commands are there: save point, commit and rollback. Rollback is used to undo the changes, and commit is used to save the changes permanently, and also there is a command called as a save point. Okay, so here I am not going to tell you about save point, but here I am focusing on rollback and commit. So here as soon as you perform commit, you just come back to previous position where you are. Means it just like a undo operation. Rollback is nothing but a undo. Means suppose you have made a particular change and you come to know that changes are not valid, then you can undo the. Means rollback is nothing but a undo. So in that case what is happening? Transaction t1 is rollback. So whatever the 20,000 added by t1, that is cancelled. That means the initial value for e-loan is 50,000, but t2 has read its value as 70,000. So that's why it is called as a dirty read, because transaction t2 is reading the uncommitted value. Unless and until transaction is not going to perform commit operation, another transaction don't have to read that value. Suppose that transaction is reading that value, then there is a possibility of dirty read, just like happening in this scenario, that transaction t1 has performed some change but it has not committed its changes, and another transaction has read the value, and after that transaction t1 has performed rollback. That means whatever the change made by t1 is what? Cancelled, but t2 has read the new value which is not there in the database. So it will cause a problem that is called as a dirty read problem. Okay, so this is what a second problem occur in the concurrent execution of a transaction. Then the third type of problem is unrepeatable read problem. This is a third problem that is caused in case of a concurrent execution of a transaction. So what is unrepeatable read problem? So in case of unrepeatable read problem, again maybe the case that two or more transactions are there. So in this case what is happening, that first transaction may read some data before updation and some data after updation. So in that case problem may occur. So I will explain with the example, don't worry about this. So in this case, in unrepeatable read problem, you need to just understand that one transaction is going to read particular value before updation, and same value it is going to access after updation, before updation and after updation. So it causes a problem. So let's discuss this with the help of example, that is unrepeatable read problem. Okay, so here transaction T1 wants to perform aggregate operation sum. Okay, that means this is a banking example where transaction T1 has to perform aggregate function sum. That means it has to sum total amount present in the account of all account holders in the bank. So what it will do, it will add the amount present in every account. Let's say in this case total 5 employees are there in the 5 accounts are there in that bank. So transaction T1 wants to perform add operation, that is sum operation. Okay, transaction T1 wants to perform aggregate function sum over all these 5 account, and T2 wants to perform operation. T2 has also accessing this account 5 account and performing some operation. So in that case we'll see how problem may occur. So initially at time T1 transaction T1 will read the value for employee ID 1. So its initial value is 10,000. Then T1 is going to read the value for employee ID 2. Again its value is 10,000. So it is performing sum. So this 10,000 is added with this 10,000. So it is 20,000. Then at the same time T2 comes and it is going to read the value of employee ID 3, so which is 20,000, and T2 perform addition operation, deposit operation, so its value is 30,000, and then transaction T1 comes and it is going to read the value of employee ID which is 30,000. Okay, which is updated by T2, and this 30,000 is added with this 20,000, so it is equals to 50,000. So it is called as a read after updation. That means T1 is reading the value of employee ID 3 after updation made by T2. That's why it is called as a read after updation. Okay, then T1 will read the value of employee ID 4 whose value is 40,000. So this 40,000 is added with this 50,000, so we got 90,000. But here what we have written there, read before updation, because in this case T2 wants to perform update operation on employee ID 3, but before that updation T1 has read the value. So in that case it may it face a problem. So see here, now T2 perform read operation on E loan, employee ID 4, so its value is 40,000, and then 10,000 is being added to this account, and then its value is 50,000. But what is the value read by T1 for employee ID 4? It is going to read T1 is reading the employee ID 4 value is 40,000, but actually it is 50,000. So this is what T1 has read the value of employee ID after updation, and T1 has read for employee ID 4 before updation made by T2. So in that case T1 will not get final sum correctly, because it is going to read some value before updation and it is reading some value after updation. So T1 will not means the task of T1 is not completed properly. In that case you may face a issue. So this is called as a unrepeatable read problem. So these are the 3 problems occur during concurrent execution of a transaction. One is a lost update problem, second one is a dirty read problem, and third one is a unrepeatable read problem. So I hope you understand what are the problems that may occur during concurrent execution of a transaction. See, concurrent execution of transaction is very beneficial because it saves your waiting time, but you should be very careful because there is a possibility of this 3 problem that may occur during concurrent execution of a transaction. Thank you.